चलिए दोस्तों शुरू करते हैं without wasting a time. Today our topic in the lab is segment routing T with explicit path, and where we'll use the prefix-sid and adjacency-sid. So this is the topology we have, and in this topology I already configured the ISIS. We are using ISIS as a IGP protocol, and I have also done the segment routing configuration regarding to node SID, and I have configured the segment routing global block 16,000 to 17,000 all over the on all the node on all of the routers. We are using a SRTE block 16,000 to 17,000. So as we know, IGP select a path based on the low cost, and in some case, in some scenario, we have a requirement to use the backup path. Like in this case, if we have to send a traffic on the P1 to P2, normally IGP will select the lowest cost upper path. But if I want to send a traffic from this path to this path and this path, let's say our required path is P1 to P2, P2 to P3, P3 to P4, then P2. So in that case, traffic engineering can help us. So here in this lab, we will use the segment routing TE, and we will get this path with the help of prefix-sid and adjacency-sid. As we have seen in the last couple of videos, prefix-sid or node-sid are the global segment, and these like are the loopback of the router. So every node have a unique prefix-sid value. Like for the P1 prefix node SID and prefix 16,001, for this 16,022, like mentioned on the nodes. And second thing is adjacency SID. So adjacency SID, we can say that it's like an label, or we can say SID which represent one link. Like we have another this link between the P2 to P3. We can say that this is the 50,005. This representing this link. Okay, so SID for one link we can call the adjacency SID. And further adjacency SID have a two type, L2 and L3 adjacency SID. L3 adjacency SID we can see in this topology, we have these are the entry link, and L2 adjacency SID can be used in the bundle. Like if we have a bundle on bundle, we have a multiple interfaces. To each interface we can assign a L2 adjacency SID, and that can be used for the OEM purposes, operational maintenance purposes. And one more thing is urgency SID is when I say urgency segment is local segment, so means these value are the locally unique. Okay, these value are not globally. These are the local segment. Local segment means a remote node. When we talk about the like for this link, we have a say 50,005. So this remote node will not install this SID in the forwarding plane. Only the neighbor routers, like for the P2 router, like this neighbor router, only neighbor router will install this SID in the forwarding plane. And these agency SID are dynamically allocated. When I say dynamically allocated means these SIDs are not persistent. So dynamic value are not persistent over the reload and restart. So when the router reload or link went down, so this urgency SID value will get automatically changed, as these are the dynamically value. So this is the reason on this link between P2 to P3, we are going to manually assign this urgency SID, and this urgency SID value will come from the segment routing global block, segment routing local block, which we are configuring on the router P2 50,000 to 60,000. So what is the use of segment routing local blocks? So you can say that these are the range of the label which we can use for the manual allocation, like for the layer 2 agency, binding SID, and BGP peering SID. These block value can be used. So, and we will do the configuration in the lab in 4 steps. Like first step, we will do the manual verification. First step, we will do the verification within the P1 to P2. We will see this will be taking the IGP path, and after that we will configure the segment routing local block on the P2 router. That from that block we will use the adjacency SID, persistent adjacency SID, for the link between P2 to P3. And after that we configure the manual agency SID on the link between P2 and P3, and after that we'll configure the TE relative config on the PE1. So we will basically we will define the policy. In the policy we will define the explicit path. On this path we will mention the all of the label how the traffic we want to send. Like we want to go from the P1 to P2, so we will first put the in the policy, we will first put the prefix prefix-sid node 16022. After that, we want to use this link is from this three link, like a P2 have a three link, one with the P1, one with the P3, one with the this P4. So we want to use the link P2 to P3. So we'll put the urgency seed, persistent urgency seed, which will configure the manual 50005. Okay. After that, here we want to use this link P3 to P4. So we will see the value, what is the value of the urgency seed between this router. So we will put that value. And after that, from this P4, we want to send the finally traffic to the this P2. So we'll put the node seed of P2. So let's jump to the node. So this is our first node. Let's verify the current state without any PE. So let's take the route first, P2 loopback. This is the route we are learning from the two path, as this router P1 is linked to the two provider router. Let's check the forwarding plain entry and this forwarding for this prefix. Let's quickly do the trace route. So this router IP. Okay, and that's it. So we are getting the label path, getting the 3 hop, and in the mpls forwarding, it's showing the two path. We get the intervention layer 1 and 0, and these are the prefix-sid labels and protection, correct? So let's jump to the node P2, where we are going to define the SRLB and persistent seed addresses. So this is your P2 router. On this router, we want to define a SRLB and we want to define the persistent urgency seed. But before that, let me show you the some few verification. We have a 4 ISS neighbor here. This is the P1 directly connected with this node, and we want to configure the persistent urgency seed from P2 to P3. On this link, we'll configure the persistent urgency seed. And let me quickly go to the connect config. At present, on all the router, we have enabled the ISIS and we have enabled the segment routing in the ISS process, and we are assigning the nodes in on the loopback on the basis of loopback port octet. So this router loopback IP is 22.22.22. This is the fourth octet. This is the fourth octet number we are using as an index here. And I have defined the global block. From this block, we are assigning the node seed or prefix-sid. Let's jump step one. Let's do the SRLB segment routing, local block configuration. Segment routing. Here we can check the option also. So these are the option we have. And let's go for the local block. And this is the I'm going to define 50,000 to 60,000. Let's do commit. And as we know, this block will be useful to manually assign the label for the agency seed and to agency, correct? On for the binding seed and then BGP seeds. And let's now, so as we can see, we have this gigabit Ethernet 5 link which is connected with the P3 router. On this link, we want to assign a persistent urgency seed, and that persistent urgency seed will come from the segment routing local block. From this block, it will be able to use. Let me check. So run first interface IS continuous router IS 4 interface gigabit Ethernet 005. Okay, so this is the on this link in the ISS process in the address family, we will define the persistent urgency seed from the SRLB block. One more thing is segment routing TE is only supported on the point-to-point interfaces. It's not supported on the broadcast interfaces. So on the all of the interfaces which are in the part of the ISI, we need to define this point-to-point network type, point-to-point. And let me show you how we can check this adjacency seed if you want to check. As we know, adjacency seed are dynamically allocated and these are not persistent. So let's show ISI. So once you run the command show ISS agency detail, so it's showing the all of the agency here. As we know, we can see that we have an four links here. So all the four links we have an two agency sheet. One is the protected and one is the non-protected. Like for the gig 003, this is the dynamically allocated value. For the gig 001, this is the dynamically allocated value. And same way for gig 005, this is the dynamic value. Correct, and this value are not persistent. This will be changed when the router reload or some process restart happens. So let's go to the configuration mode. Now let's assign this SID. Router as a core interface. I'm going to the interface. This family here. You can urgency SID. You can see index. So what we can do on the basis of interface number, like see we have an interface 5. I'm putting the index 5 here. Then I will assign the two urgency seed. One is the protected and one is the non-protected. Like we have seen in the show urgency table, we have a two seed. Urgency seed and non-FRR seed. Okay, so this is the protected and one number I am taking 5 to 6 I am doing. So, as we know, our SRLB block is starting from the 50,000. So this protected seed will become the, sorry, I have done the wrong. So let me correct it here. This is fine, but this will be the non-protected seed. Let me do first no here, then and this is for the non-protected we did not want to option. We don't need to put any option here. Okay. So our protected seed will be 50,005 and non-protected seed will be 50,006. Let me do the commit. Let me verify the configuration. This is here. So if we now again check the show ISI agency detail. Okay, we should be able to see here. You know, these are the only showing entry. This is show ISI agency seed persistent. These are the two values. 50,005 is the protected one and 50,006 is for the non-protected, and this value came from segment routing local block. As we put in the index number 5 and 6 on the basis of interface number, so this value 50,000 plus 5 become the 50,005, 50,006 become the 50,006 for the non-protected. Index number we have defined on the interface. Router as 4 interface 005. Put this. This is the interface is connected with P3 router. So now we have this value. So we have this value. We have to be noted. 50,005 is our value on the link urgency sheet value, which is the link connected P2 to P3. Let's jump to the P3 node to get the dynamic urgency value. So here we are on our P3 node, is the neighbor of P2. So let's check the show ISS neighbor. Let me quickly show you the configuration here. Configuration all of the node is same as we have seen in the P2 node. In same way, this is the ISS process configured, segment routing enabled, fixed and node seed value is defined on the basis of loopback, index number, port octet, and that's it. And global block is segment routing 60,000 to 16,000 to 17,000. Here we are not going to define the persistent urgency seed. Only on the P2 node we have defined. Uh, Now from this node, we want to send traffic toward the P4 node. So here from on this node we use the dynamic urgency seed instead of using a persistent urgency seed. As we have already seen how to configure persistent urgency seed and SRLB block on the router P2 in the previous node. So how we can get the dynamic value of the urgency seed? We have to run the command show ISIS urgency detail, and this is our node P4 and interface is gigabit 003. Enter, and where is the gigabit 003? This is our node P4. So here are the two values, urgency seed and known FIR. So we will use this. We can use any of the value. Let's say we'll use the 24004. So on the P2 node, we have configured the persistent urgency that is the 50,005. Here we have an urgency is 24,004. Let's go to the head and router to configure the PE policy with the help of these labels. So this is how our explicit path will be look like. As this is the first label. First we want to send a traffic to the P2. So we have mentioned this node seed value 16,022. This value. After that, from the P2 node, we want to send a traffic to P3, and we have defined the persistence urgency seed on the interface 50,005. Data value I put on the second number. After that, from the P3, I want to send the traffic towards the node P4, and we have checked the dynamic urgency seed value on this link P2, P3 to P4 on the gigabit 003 interface, and that value was the 24,004. And after that, from this P4 node, we want to send the traffic to P2. So for this PE2, I mentioned the prefix value 16,002. So let's jump to this PE1 and do the SRTE configuration. So here we are on the head end router on the PE1. Let's check the quick verify to ISS neighbor. We have no two neighbor as usual earlier. Router ISS. This is also the same configuration. We have defined the router ISS core process, enable the segment routing, index defining the 1 at the loopback address is 1.1.1. Here we are on the fourth opcode. We are using the index number, and here we have an the global block. From this global block, nodes in the prefix-sid value are coming 16,001. So let's jump to the configuration now. Let's check the destination out before that. 2.2.2.2. So this is showing via interfaces, correct? And if we do the swing mpls forwarding, fix for the P2 loop back. So this is the state here, right? So I do the trace route, go to source 1.1.1, change the P hop, actually in the load balancing ultimately because we have an a2 path and host is same. So already prepare the config. Let me do the copy and paste. So let me paste it full and then I will change the configuration here. So I will show you. So this is the head end configuration required. What we're doing, we're going in the segment routing under traffic engineering, and this is the path we have defined in segment list. This is the path name. I'm giving the optimal path to PE2, and then we are putting these labels which we have seen, correct? This is the prefix-sid and node seed for place. That is P2, correct? This is the prefix-sid and node seed with the P2 router. This is the urgency persistence seed which we have configured on the link P2 to P3, and this is the dynamic urgency seed we are putting, which we have seen, which we check on the P3 router, which is connected to the P4, and This is the prefix-ing node seed of the AND node PE2 router. Here we define the policy name. I will mention the P2 PE2 PE PE2 traffic engineering, color, the number we are using, endpoint. So this is the endpoint of the tunnel. This is the PE2 loopback, and with the help of auto route, we are announcing this tunnel route in the routing table. And when after that we are defining candidate path, and we have given the preference handler. So multiple candidate path can be here, and accordingly higher preference the preference. After that we are calling this explicit segment list, and this path name here we are calling. So let me do the commit. So done the commit. So let's do the verification. So segment routing, traffic engineering, policy. Here we have a now. This is the SRTE policy database. We can see that color we are defined. This is the endpoint it's showing. This is the name of the tunnel. The dynamic calculated. Operation state is up. Admin is also up. It's showing. And preference we have configured the 100. State is active. Name we have in PE2 to E. And this is the binding seed. It's requested dynamic. We can use the binding seed manually also. Uh, we'll cover in the upcoming lab what is binding seed, how it's work, but as of now we can understand binding seed is the collection of seeds. Okay, so this is the value 24005. You can say this is the binding seed, and this seed have these are the values, so which we have defined the label path is binded. So if we now check the show route 2.2.2.2, it will see that earlier it was showing the physical interface path, now it's showing the next stop is the SRTE. Okay, earlier it was showing this, like this one is showing. So now it's showing the tunnel. And after that, if we see the mpls forwarding table prefix for 2.2.2.2 slash 32, so it will show the, so this is the local label, and pop is showing the outgoing interfaces. And if I check the show sef for 2.2.2.2 slash 32 in detail, which is showing that in a point to point interface is this. Okay, let's check forwarding state also. Show icons, routing, traffic engineering. I think this forwarding policy detail. Here we can see this is the color, endpoint name, binding seed. This is the how to enable it with. This is the interface is going out from here, and this is the label stack it's showing. Let's do the trace route 2/32. Just do the simple trace route here. You can see that correct. So it's taking the similar path which we in this, the label stack is following. This is our persistent seed, persistent urgency seed, and this the from the dynamic between the P3 to P4. This is a couple of more commands. Show ISIS database. On the P2 node, we have defined urgency seed to the verbose. Here, correct. So this is the, now we are getting the blocks SR local block size here. You defined 50,000 to 60,000. So this is the range is coming 10,001. And these are the two product persistent urgency seed we have defined, and P flag is set. This means these urgencies are manually defined. So this is dynamic. This is where P flag is 0. So similar way other